All right. When baking, the ratio of ingredients is important to maintain. The table shows common recipe for pizza dough. Too much or too little of any ingredient will not create a good dough. Okay, think about like flour, so flour, salt, yeast, water, and olive oil is used to make pizza dough. What if you add too much flour? What's going to happen to your pizza dough? It's not going to bind. It's going to be super flaky and it won't stay all together. What if you add too much water? Yeah, it'll just slither apart because it'll kind of, yeah, melt. That's a great way. It will kind of disappear a little bit if you have too much water. Okay, so keeping a consistent ratio for your pizza dough is really important. And so we can take a look right here of 3 cups of flour and 1 cup of water is that ratio that we've got. Okay. All right. In this ratio, cups of flour to cups of water is 3 to 1. So remember from yesterday's video, we said whatever comes first is the number that's first. In this case, flour to water. So 3 to 1. All right. You guys should remember that from last year. Okay. Suppose you want to make 2 batches of dough. Is the ratio of flour to water the same? Okay. When they say is it the same, it means does it simplify to the same thing? Okay. So we've got 3 to 1 as your ratio. And again, we are writing that as a fraction. That's going to be equal to, okay, what if you want to do 2 batches? Well, for 2 batches, we're going to need to multiply by 2, right? So you're going to have 2 cups of water, which means you have 6 cups of flour. Okay. What if I wanted to make 3 batches? 1 times 3 is 3. 3 times 3 is 9. Recognize these all simplify to 3 over 1. Okay, so your ratios are the same. All right, the bar diagram shows the relationship between flour and water for different batches of dough. So another way, I just showed you with fractions how we could look at this. We could also use a bar or those double number lines that I showed in the video yesterday. So if we have 2 batches, okay, that's 2 cups and 6 cups. 3 batches, 3 cups and 9 cups, just like we showed, okay? If you want to utilize these ways of doing it, absolutely. But when we get into those fractions, it makes it a little more difficult to look at, okay? When all of these quantities simplify to the same thing or they have a constant ratio, okay, so those were a proportional relationship, same with the ones we did yesterday, because they all had a constant ratio. Their simplified versions were the same, okay? For example, 2 cups of flour for every 1 cup of sugar, okay, that would be 4 and 2, right? 8 and 4. Those all simplify to 2 over 1 as your constant ratio. Actually, let's talk about this. There are some ratios that are not proportional. For instance, this example that they give here says Pedro is 14 years old and his little brother is 7 years old. The ratio between their current ages is 14 to 7. So Pedro is twice as old as his brother. Will he always be twice as old as his brother? No, because when he turns 15, his brother turns 8. And is he now twice as old as his brother? No. When he's 21, his brother will be 14, and he's no longer twice as old, right? Okay. So that is not a proportional relationship because that doesn't simplify every time. Let's take a look at an example. The recipe for a homemade glass container indicates to use a ratio of 1 part vinegar to 4 parts of water. Elise uses 3 tablespoons of vinegar to 12 tablespoons of water to make the cleaner. Is the relationship between the vinegar and the water in the recipe and the vinegar and the water in her solution a proportional relationship? Yes or no? 1 part vinegar to 4 parts water. Is 3 to 12 does it follow that? 1 part vinegar to 4 parts water. You're not using any other numbers, just 1 and 4. 1 to 4. Again, Order matters. So 1 part vinegar to 4 parts water. Now we're trying to figure out, is this equal to 3 parts vinegar and 12 parts water? Are these two equivalent? Well, what did you do to 1 in order to get 3? We multiplied by 3, right? Well, 4 times 3 is what? 12. Okay, so because of this, yes, they are proportional. All right, and you can see 1 part vinegar, 4 parts water. Again, turn that to your 3 and you get 12. Okay, you can use that as well. All right, 5-mile taxi ride into in one city costs Anaya $25. So 5 miles is $25. How would you write that as a ratio? I think you're one step ahead of me, probably. Okay, go to just that very first sentence. So we're looking at only this part here that says Anaya's 5-mile ride costs $25. Okay, we're only looking at the first sentence, guys. Don't just go through and pull numbers from, that doesn't work anymore. That might have worked in 3rd and 4th grade. It does not work in middle school math. You have to read and figure out the meaning of the words. 5-mile taxi ride is $25. Okay, 5-mile taxi ride is $25. So we're writing that as a fraction. 5 over 25. Okay. Next sentence, a 4-mile taxi ride in a different city costs $18. We're writing a ratio. 4-mile taxi ride in a different city costs $18. So the ratio of miles to dollars in the second city is going to be 4 to 18. Okay, that is miles to total cost. All right, is the relationship between miles and cost between the two cities proportional? Are these things proportional? 5 divided by 25 simplifies to what? 5 divided by 25. So we're going to simplify to 1/5. Okay, so I had several people tell me 5. You guys took 5 divided by 25, but because my fraction has the 5 on top, okay, it's going to be a number less than 1. Okay, so 5 times 5 is 25, that's true, but because the 5's on top, it's 1/5. We just take the reciprocal of that. That's the flipped fraction. Okay, remember that word from last year. Okay, reciprocal, flipped fraction. Okay, and 4/18 simplifies to what? 2/9. 2 goes into both of those. These are not equivalent here, y'all. Those are not equivalent. Okay, because this does not simplify any further, and neither does this, and they are not the same.